Welcome to 9.5. You should have in your packet a sheet of notes that explains how to do this a little bit. It's almost a total replay of what we've been doing. So if you've understood really well 9.1 to 4, you should be in really good shape. We just have to add on one small concept. If you haven't been so good, it's a chance to catch up, and we'll just kind of reteach this. So if you've been struggling on things, you'll like what I'm about to do. If you have not been struggling at all, you're going to be bored for about the first 3 minutes of this video. Everything today is going to be an x squared kind of graph, which is going to be a U shape. Anything with a squared in it is a U. We've had also some absolute values with bars to make V's. Those are not in effect today. I recommended back on 9.2 that you just memorize how to do the basic shape, which is put a dot at the origin, and that's going to be called the vertex. And then build from the vertex. Over 1 square always goes up 1. Over 2 squares always goes up 4, because 2 squared is 4. If I were willing to go 3 squares, I'd be over 3 and up 9, because 3 squared is 9. Or over 4 would take me up 16, but I don't have that kind of space on my hands. And then when we work to the left, it just mirrors it. Left 1 is also up 1. Left 2 is also up 4. We want to connect the dots on that. And eventually we learned that this line that's cutting the graph in half was called a line symmetry. And we spent a good bit of time moving graphs around, right, left, up, down, all of that kind of stuff. We've been figuring out where the vertex would be, figuring out where the line of symmetry would be, writing these little descriptions for things, and that's all still alive and well. There's one new word today on this, which is either going to be a minimum or a maximum. This graph right here has a minimum because that's the lowest it goes. If you were here, I could ask you, and we'd have a big pause, and someone would come up with it, what would make a graph have a maximum? This graph has no maximum because it's going to go up literally forever. There's no top to this. There's no highest point because it goes forever. So I'd ask you what makes a graph have a minimum or a maximum if you were here, and somebody would come up eventually with the idea that if you flipped it. If you flipped a graph, it now has a maximum instead of a minimum because now it has a highest point and it goes forever downward. But in the homework we'll do today, when I step over here toward the right and start to do some problems, you're going to be asked, as always, to write a description for what's being changed, up, down, taller, wider, that kind of stuff. A vertex list, a line of symmetry list, a max or min decision, and then we're going to look to graph some things. So if we go to tackle this one, if you're willing to self-test yourself, I would suggest for a minute, pause the video, see if you can remind yourself of what these numbers are doing. Up, down, left, right, taller, wider, whatever. If you don't want to do that, just keep listening and I'll just do it. So on this, the 3 would make us 3 times taller, because anytime there's a multiply number, it does a stretch. It has to multiply inside the parentheses to be a wider, because x stuff goes this way, and if we're not in with the x, we must be working the other way. We're 3 times taller. The 1 is in with the x. Adding and subtracting numbers make us just move, not stretch. With the x is a right or left move. Subtracting 1 would go right 1. And then the adding 2 is going to be another move. Adding always makes us move. This would be up 2. For this, I would go 4 times as tall. For the same reason, I just went 3 times as tall. Multiplying numbers make you stretch, and if it's not in the parentheses, it's tall. I'd go left 6. For the same reason, this took me right 1. This takes me left 6. And I'd go down 7, because this is taking me down 7. Same reason that took me up 2. Adding makes you move, and it's not in the parentheses, so it's up or down. And I'd also get a flip upside down. This negative that multiplied causes a flip. Upside down flip is whenever that's not happening inside the parentheses. So this next one, if you got the hang of it now and you didn't self-test before, self-test yourself, see if you can do this one without me, and then unpause it when you want to. But for this, we're going to use the 2 to go 2 times taller. We'd use the 4 to go left 4. We'd use the 5 to go up 5. And it would be another flip upside down because the negatives multiplying not inside the parentheses. Quick skim of your homework. There is no wideness happening because there's never a multiply inside the parentheses. If I want to do wideness, I have to multiply inside. That will never happen. All of the multiplying numbers today are going to be tallness. There is no flip sideways either. All of the flips are going to be negatives out in front of the parentheses. It'll flip upside down. There are no sideways flips. So they are not giving you like the full range of anything a human could give you. They cut you a little bit of a break. So there is right, left, there is up, down, there is tallness, there is some flipping. Additionally, as I look at this while it's on my mind, on every single problem, I'm going to want you to write the description. Every single problem, the vertex, the line of symmetry, and the max or min that we're about to do in these columns here in a second. But you only have to graph the first 8. The first 8, the directions say graph, and I agree. Starting on 9, it says without graphing, and I agree, because they make the numbers kind of crazy. Number 10, for example, is 10 times as tall. I really don't think you want to graph it. It's 10 times as tall. They do some decimals, they do some fractions, they do some things that make you mad, but we're not going to have to graph them, so it shouldn't make you mad. If I made this be a 700, it really wouldn't hurt you any to write down 700. You'd be pretty grouchy if I made you graph that, I understand, but we won't graph any of the weird numbers. But if some of the numbers are weird, it doesn't really affect your ability to write a description. So if this was a 0.5382, and you said up 0.5382, that's pretty harmless. The vertexes are caused by moves. Last time we did this, a lot of the vertices or vertexes, they're both the plural of vertex, vertexes or vertices, they were at the origin because the first time we did a list of vertexes, there weren't a lot of moving on the problems, like half of them maybe. Today everything's moving. So if we're right 1, that makes this be a 1. If we're up 2, that makes this be a 2. The right-left number is always first for the x. The up-down number is always second for the y. So left 6 and down 7. Pause, see if you can do this. If you want to self-test, you saw 1, see if you can do the others by pausing and then coming back. We're going to go left 6, down 7. This is going left 4, up 5. You might remember the line of symmetry lines were always this way. We have these U's. The line of symmetry lines have to go straight up and down. It's always x equals lines that go straight up and down. So without any thought, you can just write x equals for the lines of symmetry. And then it's just going to be the x number we already came up with. We already came up with a 1, so just reuse the 1, because we were right 1, because the problem had that 1. This would be a -6, because I just recycled a -6, because it was left 6, because of the way the problem had that 6. And then this, even if I forget to say pause and self-test, I hope by now you realize just to do that every once in a while to predict this answer, this would just be that. The max or min, you're going to have a min anytime it didn't get flipped. That first U I did at the very beginning had a min because there was no flippage. So this is a min because it was not flipped. And then the number for the min is going to be a 2. The lowest that's going to go is 2 because of this 2. Or because we were up 2. Or because of the 2 in the problem. Look wherever you want to look to find the 2. But I think the easiest thing is follow this to there and follow this to there. I don't think you could beat that as long as you got this right. Okay? If this is wrong, then you're doomed. So be careful on your description, and that should lead you to the vertex. And if you're careful on the description of the vertex, I would just rely on the vertex to lead you to the other numbers. But just be careful on those. If you want to self-test, go for it. But this one's going to be a max instead of a min. because we're flipped. So when you flip, you don't have a low, you've got a high. The max number there would be the -7. This would also be a max because we're flipped, and then we get a 5 from that number. And then I'll graph some stuff because some of them we're graphing, again, 1 to 8 we're graphing. So if I graph this first one, you always do the vertex first. So write 1 up 2 to get to this position. That was our first thing. So write 1 up 2. So the vertex. And then build from there. I'm 3 times as tall. So my usual height is 4. But I need to go 3 times as much as that. So I need to travel 12 squares. So this is 2. I'm going to have to travel 12 more squares all the way up to 14 for the highest high, that is. But my first move, over 1 is not the usual up 1, go 3. On the left and on the right, both. When I travel 2, I've got to travel 12 more squares all the way to line up with 14 in both directions. And that would be a very tall, 3 times as tall kind of use. And then I'll stroll way back to the left to create some space. For this one, I'm going to need a pretty good amount of space for this because I'm going left 6 and down 7. So I'm also flipped. So let me go like this to get started. Here's my original origin. 3, 4, 5. Left 6. 1, 2, 3, 4, 5, 6, 7. So I'm down 7. I'm left 6. Always do the vertex first. That's where I would be. Then I'm going to be going 4 times as tall. So usually the distance I need to travel is 4. 4 times as tall is going to be 16 squares. 16 more squares would take me all the way down to -23. So that's taking up a pretty big amount of space. And I don't think they're going to do something this extreme to you in the homework. They are in the section we're not graphing where they had some numbers that were not so, but I don't think that's going to happen on these. But for over 1, we go down 4, both sides. Over 2, we'd be way down to 23 on both sides. And you would be getting a really pretty big kind of U. I should have easily spaced to do this one because this one's not as big of numbers as that. So if I want this, I'd be left 4 up 5. So if I go left 4 up 5, I'd have something there-ish. Always look to do the vertex first. I'm flipped, so I'm coming downward from there, but only twice as tall. So over 1 would go 2 squares down. And over 2, instead of down 4, would be 8. So if I started at 5 and go down 8, I'd be 3 underground. And that wouldn't be nearly as tall as the other one had been. That's what we're doing. Syllabus knows the homework numbers. It should feel like a large repeat of what we're doing. The only add-on today was the max-min choice. But other than that, it's just doing what we've been doing, so I hope you have success with that. If you don't email me, we'll try to work it out by video conference on Zoom or some other system.